All right, Math 9 3.2, this is adding rational numbers. So we talked about what rational numbers were in 3.1. Talked about the fact that fractions are rational numbers, right? The basis is any number that can be written as a ratio of two integers. So whole numbers, positive or negative, that can be written as a ratio. So like 3/2, that's a rational number. What's the only number that we can't have on the bottom to call it a rational number? There's a problem with one number in the denominator. What is it? 0. Right, we cannot divide by 0. Okay? It's mathematically impossible. Think about what division really means. Let's just pause for a second. If you divide by 0, if I have $10 and I need to split that between two people, that's easy. That's 10 divided by 2 equals 5, right? So if I have $10 and I want to split it between two people, how many dollars does each person get? $5. Now if I have $10 and I want to divide that between 0 people, how many dollars does 0 people get from 10? 0. Well, you don't get $0. You still have $10. Because there's 0 people, how do you even divide that? You can't even divide that up between 0 people. It's like the $10 has to disappear. You see? So when you divide by 1, that one person gets all 10. When you divide by 2, they get 5. When you divide by 0.5 people, you can even do that. Like every half a person on average, each person would get $20. 10 divided by 0.5, okay, this is like a totally different lesson, but 10 divided by 0.5 is the same as multiplying by 2. Oof. Okay, now we're blowing things up here, aren't we? Okay, so we won't divide by fractions just yet here, okay? But you can't divide by 0. All right, so rational numbers includes integers, positive, negative whole numbers. Now you can add or subtract or multiply by 0, you just can't divide by 0. All right. So here we have, in the lesson here in your notes in front of you, we're going to talk about decimals, we're going to talk about fractions here, we're going to do a couple word problems, and that's going to be our lesson for today. Okay? So let's take a look at this. Adding integers. Okay, when we add integers, we're just going to focus on adding, not subtracting today. So when we add integers, really easy. Okay, it's really easy. If you want to use a number line, you certainly can. And I'll just put a number line up top here, on top of the notes. And you can do this too if you want. You don't have to, but I'm going to put a number line here so that I'll be able to show you how we can add some integers. Now, the snorkeling, you've probably never heard of this before, but how many of you have ever been diving or have ever been swimming in the ocean or even just swimming in a deep pool and you go down to the bottom? I think. Okay, you've been swimming? I went to Mexico with my family this year. It was a great trip, and I got to snorkel in the ocean. It was great, and I picked up some seashells, saw some fish and stuff. Really good. So when you snorkel, you kind of start at the surface, and then you can go underneath the surface a little bit. And then if you got that thing in your mouth, that goes up by the side here, and that you breathe out the top of the tube way up here, so you can go under the water a little bit, and you can swim and kind of like float on top of the water, and you're breathing up here, right? Okay, so those of you that haven't done it. But you can take a big breath, and you can dive way down to the bottom too. You can go down, and everything can go under the water. It's no problem. You've got air trapped in here. When you take a big breath, you've got the air trapped in there. So that when you come up to the surface, you just blow out the air that's in your mouth, and that air column pushes the little bit of water that might have gotten to the top, boom, just blows out, and then you can breathe freely again. So you can just take a breath and go down. So you can go down deeper, you can come back up. So sometimes going down deeper is like adding a negative depth, okay? And so sometimes when we talk about a number line going forward and backwards, or positive way and negative way, sometimes that's like, maybe I don't understand that. But if you think about it up, down, you can go, here's the surface, maybe 0, and then you can go down to negative depths, negative distance, right? And then you can come back up to 0, and you can go above the water. So think about snorkeling going down and up. That might help too. Okay, so let's use this number line to add this one. So -1 plus a +2. Now, a negative value, you can think about a negative value, okay? On the number line, let's see, here's 0. So here's -1, okay? There's two ways you can do this. You can always start at 0 and you can kind of draw a representation for the first number. Anything that's negative kind of faces backwards towards the negative. So this is a -1 here, okay? That little arrow there. And if I add a +2, it's kind of like from the number line here, I'll just zip down a bit, from the number line, you're adding 1, 2. So you're adding like an arrow that's a length 2. And where does that take us? Well, if I have a -1 and then I add a +2, I end up right here at +1. Okay? So this equals +1. Now the other way to think about this, and this is the way that I do it, I don't really do all the arrows so much. I don't envision the arrows so much, but what I do is I say, if I'm starting at -1, that's the first number that I see there, okay? I just kind of start my point at -1. That's where I start, at -1. And then what do? I add 2 units to it, add +2 units. So I'm just going to jump like this, 1, 2, and where do I end up now on the number line at +1? So you can just start at the first number, whatever that first number is, start there on the number line, and then move either to the right or to the left. And when you're adding, it's easy. Let's keep going. What happens if I have, in B here, I have a -2, and I add a -6. So I'm going to have to change my number line just a bit, okay? So I am going to put 0 over here. Oh, you might not be able to see that. Just give me a second.
Can you do the number line under the...
Yes, yeah, you can do the number line under each one, which I'm going to do right now, so I can just zoom in a bit. Okay, so you can start, like this is the way I do it, start at -2. I'm going to start here, and I'm going to add a -6. So this is where the arrow might come in handy. The negative is an arrow that faces backwards, and it's going to be 6 units long. I still just like to do this. I like to go, I'm going negative direction, so I'm going backwards, 1, 2, 3, 4, 5, 6. So what does that take me to? A -8. Very good. So I have a -2, that's where I'm starting, and I go back 6 more to get to -8. Again, the arrows start at 0, here's my -2, and I add to that arrow a -6 size arrow, and where do those all get me? They get me to -8. Okay, so either way you like to do that. All right, this one over here on the right, -7 plus 4. Number line, start at -7, and I'm going to add a +4, so I'm going to go to the right, 1, 2, 3, 4. So this is -6, -5, -4, and -3. Okay? -3. Any questions about those first 3? All right. Why don't you try the next 3 here. Try the next 3 on your own. And if you get past the 3 in the time I give you, you can move on. You can use a number line or just not your calculator. No calculators, okay? Use the number line, or you can just do mental math and envision the number line if you want. I'm okay. I don't know where you're at with this, because sometimes negative values and integers kind of freak some people out. So do whatever you need to do. Okay, so let's take a look at these. I'll show you what I did here. So again, if you start at -2 on the number line, then you move in the left direction 1 unit. So there's 1 unit, and where do I end up? -3. Anybody get -3 for D? Yeah, good? Awesome. Okay, E. Here I go. I'm going to use the arrow method here. So I'm going to start at 0, and I'm going to put my first arrow as a -4 arrow. So that's an arrow that goes 4 units in the left direction. I'm going to add to that another arrow. I'm sorry. Oh, I guess I should have started with 6, whatever. So I've got the -4, and I'm adding a -6 arrow. It doesn't matter which way you order those, actually, if you're adding, right? So there's a -6 and a -4. Those 2 arrows combine to get me to -10. Am I get -10 for E? Awesome. And then 8. So here we go. Do the arrow one again. Start at 0. Draw an arrow that is 8 units in the right direction, and then another arrow that is 12 units in the left direction. On the number line, if you count those up, you should get to -4. Okay? Questions there? All right. the number line is helpful to visualize, but you don't have to draw a number line every time, okay? So like I say, what I want you to do is I want you to move into doing this mentally, okay? This kind of addition and subtraction really is mental. You should be able to do that. I don't really want you counting on your fingers. It's going to be tough to go into the negatives with your fingers too, right? Like how do you go into the negatives? Not a good idea. Using a number line counting will be good if this confuses you right now, so I appreciate that. You go ahead and do that. But what I want you to try and do to get there is to do this mentally. Now these ones are going to be tougher because they're bigger numbers and sometimes we're adding more than two things. So let's try this, and I'll show you the thinking process that I go through and how I visualize this. So check these two numbers out, 5 and negative 19. Okay, so we're adding them. 5, if you add a negative, okay, that is the same as subtracting. Okay, now I know we're not talking about subtracting today, we're talking about addition today, but when you add a negative, that's the exact same as subtracting. Think about it. I have an 8 and I've added a negative 12. That's the same as 8 minus 12, right? 8 minus 12 is negative 4. So 5 minus 19. Okay, so I think about that as I'm 5 to the right of 0 here. That's where I start. And I take away 19. Okay, so 5 units gets me back to 0. And what do I have left from 19? I got to keep going. So I got to go 14 more units this way. Okay, so 5 minus 19, negative 14. Does that sound good? Another way to think about it, and again, I don't want to confuse you, but I think some of you are ready for this sort of area of thought. What's the difference, just the total difference between the numbers 5 and 19? Don't think about a positive or negative. What's the difference between those two? It's 14 units, right? So think about it. Are you going to be on the positive side, 14, or on the negative side of 14 if the negative is much larger than the positive? Okay? So the difference between the two numbers is 14. If you're subtracting the really large number, then you're going to be on the negative side, so it's negative 14. Another way to think about it is change in temperature. Okay, we talked about depth. Okay, what about change in temperature? It's 5 degrees today. That's pretty close to what it is actually outside at this very moment. 5 degrees. Let's say that an Arctic cold front came down overnight, and the forecast for tomorrow said it's going to be 19 degrees colder than it is right now. If we heard that on the radio or the TV or the internet right now, what temperature would it be tomorrow? Well, you have 5 now. It's going to be 19 degrees colder. So here's 0. My thumb is 0. It's 5 right now up here. I'm going to go down 14. I'm going to go down 5 and then another 14 degrees to land at negative 14. So you can think about like temperature as well. Okay. Let's think about these numbers. Okay, so I have a negative 5, and again, I like to think about the number line in my head a little bit, okay, that I start on the negative side. I'm at negative 5. I'm going to go up 3. See, up 3 units. What temperature does that get me to? Negative 5 takes me to what? It does. This right here takes me to negative 2. And if you have more than 2 things to add or subtract, just do the first 2 first. Write down the number, and then go ahead and do the next one. So you would collect these, or you would do this addition first, and then you would take that result, and then you would keep going, add negative 9. So now I've got negative 2 on the left, and I've got to take 9 more away. Where does that leave me? Negative 11. Right, negative 11. Okay. Are we getting it? Yeah. Another thing to remember here, again, I'm trying to give you some tools here. If one is positive and one is negative, you think about the difference between the values. If both of them are the same value, both positive or both negative, we think about adding the values. So 9 and 2 is 11. So you got to think, is this going to be on the negative side or positive? So same sign, we think about adding the numbers. Different sign, you think about the difference between the two numbers. Okay. That may be too much for you right now, and that's okay if it is. but you might remember that later, and that might make a lot of sense. That's the thought process that I go through. Okay, these are two negatives, so that means they're building on to one another. So that's like 9 plus 2 is 11, and they're both negative, so it's got to be negative 11. Okay? All right, finally over here, let's zip over to the right side, letter I. Ooh, we got 4 going. No problem. Let's see if we can do this. I'm going to go 7 plus a negative 2. So that's like subtracting 2 from 7, isn't it? That's going to be 5. Okay? Plus negative 7 plus 4. Good. Now I do the next one. What is the result of this first one? 5 plus a negative 7. Well, that's like taking 7 away from 5. And 7 is bigger than 5, so I'm going to go back into the negatives, right? Or back in, I guess for you guys looking here, back into the negatives. So this is going to be a what? It's going to be a negative 2 plus 4. Yeah. So if I've got, if it's negative 2 degrees out right now, and it's going to get 4 degrees warmer by this afternoon, it's going to end up to be positive 2. Now, if it's a positive, you don't have to write the plus sign. Okay? You don't have to write the plus sign. But if it's negative, you certainly have to write the negative sign. Okay? All right, any questions at all about this? All right. I won't fault you at all if you want to write a number line or do like the depth snorkeling chart. I won't fault you at all. That's great. Go ahead and do that. If you don't need the number line, don't use it. You know, if you want to be sure, go ahead and check. But that's how that works. Okay, let's move on to decimals. Okay, adding and subtracting decimals. Decimals are just the same as whole numbers, except we got to be careful, right? So the whole sign thing is still the same. The whole sign thing is still the same, but you have to, and you can use your calculator for this. I'm totally fine with that. You can use your calculator for this. But on a number line, if I have 0 here, again, I'm going to look at this first number. I'm going to start at negative 1.3. So here's negative 1, and here's negative 1.3. That's where I'm going to start, okay? And I'm adding to this a positive 2.1. So I've got to go 1, 2. So that's going to be just on this side of 1, and then 0.1. So I'm going to land over here somewhere. Now, again, this is a bit tricky. But on a number line, okay, we're going to go, if we add 1, this is going to be negative 0.3 where this first lands. If I add another 1, this is going to be what? What's negative? This will be a test to do this in your head. What's negative 0.3 plus 1? Now it's going to be a little less than 1, right? As we see. Okay, so 0.3 is going to be right here. It's going to be symmetrical. Does that look like 1? No, it's not 0.3. Positive 0.7 or 0.7. Yeah. So when we come across 0 there, we have to be careful. Things flip. So positive 0.7, now we've added 2, so now we just need to add 0.1. That's going to be positive 0.8. Okay, all right. Well, let's see. On our calculator, let's double check that. Now we need to know how to use our calculator. Now I have this fancy schmancy graphing calculator. That's what I have on my, you probably won't have one of those. But on your calculator, there might be a negative sign like I have. Do you see down at the bottom here? Yep. So I'm going to type negative 1.3. Now on most calculators, this is very important, on probably on your calculator too, the minus sign and the negative sign are two different buttons. And the calculator doesn't like it when you interchange those. They're not the same. They're two buttons for a reason. So the negative is when you write it in the front of all the numbers. The minus is when you write it in between all the numbers. Okay? All right, so if it's an operation, it's minus. If it's part of the positive or negative character of the number, it's the negative sign. So I'm going to do this, and I'm going to use all the brackets that they use too. And you can too if you want. Now positive, you don't have to write the positive inside the bracket, right? We just leave it as regular old 2.1. I don't even think you can, well, maybe this, I don't know if this would be used for positive or not. But when you see a positive number like this, you don't have to write the positive, but you do have to write the negative. So let's see what happens when we add these two. Oh, good. We're right. 0.8. Okay, 0.8 is our answer, and that's in the positive, of course. All right. Okay. Okay, here's the opposite way of looking at this. Let's see if we understand this. Here's the number line, and I want you to show me, or let's together determine an addition equation for this. So we're going to have some value plus some other value equals a third value. So look carefully at this number line, and let's see what we can figure out. This circle here, to me, looks like the answer, because we always should circle our answers in math, right? So that looks like it's going to be an answer. What do you make of this right here and of this right here? What do you think those mean, those two numbers?
The numbers you're adding.
Okay, those are the numbers that we're going to add. You're right. Now, which one goes first?
1.9.
Yeah, look at that. We start at 1.9. So you can write a or is that negative or positive? We should look.
Positive.
Okay, thanks. Yes, that's a positive. So positive 1.9. If you want to write the plus sign there, you can. Positive sign. And what am I adding? I'm adding. Now be careful. Which way is the arrow going? To the right. Would that be a positive number or a negative number? Yeah, positive. So we're adding a positive 1.2. And you could put brackets around there. That would be great. Okay. And what's the answer there? Okay, is it okay, it's 3 point something, right? It's just above 3. Now, are we sure that these are 0.1 values? Well, let's just check. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces in between, so you're right there, 0.1 each. So that's 3.1. I like it. I like it. I like it a lot. Anybody have any questions about that or problems with that? We're good? Everyone's looking okay? All right. Okay. That's good. Okay. Now, if you need to get your calculator out for these, I don't mind if you do. If you can do them mentally, and then check. Okay? Because really, these are just like, they're kind of just like 2-digit numbers. So if you can add or subtract 2-digit numbers in your head, you can do this. Okay? Let's give the first one a try together. When I say 2-digit numbers, because look at these are both have a decimal there, so that's kind of like I can maybe think of this as 24 and negative 17. You see that? Because I'm just viewing them like this. So do I know what 24 minus 17 is? So again, they're opposite signs. So what's the difference between 24 and 17? Well, you have to add 3 to get to 20. From 17, add 3 to get to 20, and then another 4. So what's 3 and 4? 7. Okay. So 7. Now, is it going to be positive or negative, my answer? Yeah, I've got a large number, 24, and I'm subtracting a smaller number. So it's going to be positive. So now what you do is you go back, you think, oh, these are actually decimals. So that's 2.4 and 1.7. So how does that change my answer?
0.7.
It would be 0.7 because that decimal, there's a 1 decimal place there. Okay? And there you go. That's one way of doing it. Okay? Negative 3.5 plus 6.3. I'll use a number line here. Here's negative 3.5. And I know that I have to go past 0 here, don't I? Because this number's bigger. So the question remains, how much past 0 do I need to go? Well, I go 3.5 to get to 0. And what's left over from 3.5 to 6.3? You want to use your calculator, you can, but 3.5 and 6.3. So this is almost 2 full units more, right? 2 units past 3.5 would be 6.5. So it's not quite 2 full units. It's going to be what? I'm sorry, not quite 3 full units. I meant 3. Not quite 3 full units. It's going to be 2.8 units. Okay? So this is 3.5 here to get to 0. This is 2.8 to get make this a 6.3. So that's going to be 2.8. Let's check that on our calculator. Negative 3.5 plus 6.3. 2.8. Wonderful. All right. Now, can I just remind you of something? There is a very strong math fact that we want to remember. I mentioned it earlier, but when you're adding two things, when you're adding, this doesn't happen when you're subtracting, but when you're adding two things, it doesn't matter which order they're in, right? 1 plus 2 is 3, just like 2 plus 1 is still 3. So whichever way you arrange them, okay, don't you like my animation? Isn't this great? So be careful which finger I leave up there, so I don't want to offend you. I just want to make sure I don't, no, I won't put that one down. I'll put this, yeah. So just got to be careful there. But isn't that great animation? I didn't pay anything for that animation either. Just born with it. Okay. All right. Okay, so anyways, this is early in the morning here. Tough crowd. So we can actually switch these around, and it's going to be the same answer when we add. So you might like to think of this like 6.3 plus negative 3.5. I don't know. Large number minus a small number. This is the exact same answer of 2.8. And it might not make a lot of difference with these decimals, but if we go back here to some of these other numbers, okay, yeah, I don't know. I mean, any of these would work, but you see negative 1 plus negative 2, that's still my answer of negative 3. It's exactly the same. It helps maybe when you have a negative number at the front and a positive number at the back. That's when it helps the best, because then you can just view it like subtraction maybe. All right. Oh, here we go. E. This is exciting. We have two negative numbers. That's great because it's just like adding, right? It's adding just in the negative direction. So you can do this in your head probably pretty easy. Negative 4 and negative 3. If we focus on the whole numbers, what does that get us to? A negative 7. So what about the tenths now? Negative 1, 0.1 and 0.1 is 0.2. So this is negative 7.2. That one you could probably just do in your head. All right, I'll give you a few moments once you take care of F, G, and H if you haven't already. Some of you have pushed ahead, I'm sure. But go ahead and do F, G, and H here, and I'll pop up the answers in a minute. All right, so I want to walk you through this. These are not the answers here to F, G, and H, but again, this is one way that might help you process this mentally, okay? So I just moved the decimal place over 2 times for each of these numbers to make them whole numbers. To me, that's a little bit easier on my brain to be able to subtract these. The difference between 67 and 83, okay? Remember, one's positive, one's negative, so I can just think about the difference between the two. And this is what I do. 67, I have to add 3 to get to 70. And then I have to add another 13 to get to 83. So what's 3 and 13? Is 16. So that's the difference between the two. And so I write down 16. The bigger number is negative, so that means the answer is going to be in the negative area. And then I just put back my 2 decimal places here. Ooh, whoa. That was weird. The great reset here. Okay. So I just put back my 2 decimal places there, and the answer is going to be 2 decimal places too. So negative 0.16. Anybody get that? Yeah. Good. You can put a 0 in front if you want. That's great. Would probably be best so that we can all see that that's a decimal. All right. Same thing here. I want whole numbers. So guess what? I can treat 1.25 as 125 if I move this decimal place over twice as well. So this, to me, is much easier to do in my head. The difference between 125 and 150 is just 25 units. The larger number is negative, so I've got negative 25. And then I had 2 decimal places before that. So guess what? When you add and subtract, you just retain the decimal places that you have there. Okay? Now, if they're different decimal places, you got to be careful with that, okay? These are different decimal places initially, right? And so I just made sure that I moved the decimal place the same for both, and then I had decimals that were the same. So So this is a 2 decimal number. Now this is 2 if I put 50 at the end. Okay? So they have to be the same decimal, then you can just keep the number of decimals for the answer. So negative 0.25. And finally, this one again, just like G, there's a negative value being the first one. Well, you could switch that around and do this as a subtraction, which is kind of nice. I just moved the decimal place over 3 times for each number and got myself whole numbers. This is easier for me to do in my head. Again, I'm working towards getting you to do this mentally. So the difference between 583 and 625, what I did was I said I got to go up 17 to get to 600 and then plus another 25 to get to 625. So that's, in my head, I could probably do that is 42. So this might be too much for you mentally. Go ahead and use your calculator. I don't mind, but that's how you do that. And so how many decimal places do I need to adjust for here? I moved over 3 decimal places, right? So I need to move this back 3, careful. 1, 2, fill in a 0 for this third one. Okay, so positive 0.42, 0.042 is right. Anybody get that for H? Did you get that on your own? Okay. All right. All right, I got one more thing to do here in this lesson. It is, let's see, 2 more things. Fractions. Okay. Fractions, and then I got a word problem for you at the end here, okay? So let's talk about fractions. Again, everything is the same with fractions. If you want to add or subtract fractions, you have to have a common denominator, okay? So we know how to get that. We'll get some practice here. The rules for adding integers are the same. We just focus on the numerators, right? You remember you just add the top numbers when you're adding or subtracting, and you keep the bottom number the same. So that's an important thing to remember. We do not add the top numbers and add the bottom numbers. Okay, so when you add or subtract fractions, you have to have a common denominator. -7 plus 5. That's all you need to focus on there because we already have a common denominator. So my answer is going to be over 9, something over 9. And what's -7 plus 5? -2. Right. I start at -7 and I go up 5. That doesn't quite get me to 0 on the number line. It gets me only to -2. So that's your answer right there. We always should try and simplify fractions too. I'm noticing that some of you are not simplifying your fractions. You should simplify all of your answers, which means that reduce your fraction to the lowest possible terms, okay? So we'll maybe practice that here if we come to it. All right, so B. All right, so we're adding 2/5 plus -3/5. So the nice thing is we have a common denominator already. So again, I just focus on the top numbers, 2 plus -3. That's the same as 2 minus 3, isn't it? So what's the result when I add those up? -1, and you keep that denominator over 5. Perfect. Yeah, there's your answer. All right, so C is, we don't have a common denominator here, so we need a common denominator. You can multiply this first one by 4, top and bottom, and this one by 8, top and bottom, but that's going to get you to some big numbers, and you don't want the biggest numbers always because you need to reduce those, right? So what we're going to do here is we're going to just multiply this one by 2, top and bottom. And that's going to give us -7 over 8 plus 6 over 8. -7 plus 6 is going to be -1 over 8. Awesome. Okay. All right, mixed fractions. Okay, if you have mixed fractions, turn them into improper fractions. And how we do that is 3 times 3 plus 1 is 10 over 3, and that's negative. 6 times 2 plus 5 is 12 plus 5 is 17 over 6. Okay, turn them into improper so we can focus on our denominators there. So now I multiply top and bottom by 2, and I get -20 over 6. And I'm adding these, so now I have common denominator. What's -20 plus 17? Negative 20 plus 17 is negative 3 over 6, right? Now this is what I'm talking about. That's not lowest terms. That's not a fraction in lowest terms. So I can reduce that by dividing now both the top and the bottom by 3. So that's going to be negative, negative 1, where were we? Negative 3 over 6, that reduces to negative 1 over, it's going to be 1 over 2, but my computer program is, so let's try this again, negative 3 over 6, which equals negative 1 over 2. There we go. Okay. All right, there's going to be some more for you to try, but because we're run out of time in the lesson here today, I'm going to go to this word problem. So the word problem we have here, good idea to take some time to look at a word problem. So Peter estimates that it takes him 1/4 of an hour to prepare enough dough, 1/10 of an hour to grate the cheese, and 1/3 of an hour to prep the toppings, and 2/5 of an hour to bake the pizza. What fraction of time did Peter take to prepare the pizza? So in this real life situation, we have basically fractions of hours that we need to combine, right? So what is the total time here? So if we take a look at this, we are going to add all of these fractions. So let's add 1/4 plus 1/10 plus 1/3 plus 2/5. Okay. So all of these have different denominators. So what I'm going to try and do is find the lowest common multiple. The lowest common multiple, LCM, between these numbers. So let's see. What's a number that's larger than all of these numbers that is evenly divisible by all these numbers? So if we go to 16, that does not easily divide by all of these, but it does by 4. So what about 40? Or, I don't know, 20? No. What is it? 60? Okay. Yeah, we could multiply all the numbers together. We could get some pretty big numbers. So 60 is going to be a number I think that's divisible by all of these. Might be the smallest one, I think. So let's get over 60. Good job. So. Okay, good. Yeah, that's a good point too. If you look at the question carefully, if you have a fraction of an hour is going to be 60 minutes. So a lot of times, so we might be able to use 60 as our lowest common multiple. Very good. Yeah. So 1/4 of an hour, so times 15, I guess, to get to 60. So this is 15 over 60. This one is going to be times 6. So that's going to be 6 over 60. This one is going to be times 20, so that's going to be 20 over 60. And this one is going to be times 12, so that's going to be 24 over 60. Awesome. So now we have a common denominator. We add all those up. 15 and 6 is 21, plus 20 is 41, plus 24 is 65 over 60. Now can we reduce that? Yeah, we certainly can. We can divide both by 5 for sure. There might be a larger number, but let's try dividing both by 5, I guess. So 65 divided by 5. So 5 times what gives me 65? 13. Very good. And this is 12, right? 5 times 12. So that looks like it's in lowest terms. So that's going to be 13 over 12 hours, because that's the units that I have. All right.